Let's look at some probability calculations and how you can apply Venn diagrams and maybe two-way tables in your maths questions. So here we have a question that says, in their class, 5 people play both football and tennis, and 13 people play tennis in total, and 11 people in total play football. So we're going to draw a Venn diagram that represents this data so that we can answer the questions below and how we got 6, 14, and 8 on 19. So 5 people play both tennis and football. So we can put that there. The key word here being and, so that goes in the middle. Now we know that 13 people in total play tennis. So that means that in our tennis circle here, there should be 13 people. Now we already have 5 people here. So that must mean that we have 8 people out here. Because 8 plus 5 is 13. Now, in our football one, we have 11 people in total. So we've already got 5, so therefore we must have 6. Now, how many people only play football? Now, the key word here is only. So that means we're just looking at what's in the football circle by itself. So that means that the answer is 6. How many people play one sport? Well, these people in here play 2 sports because they're in 2 circles. So this circle here and this circle in here are the people that play one sport only. So there is 8 plus 6, which is 14. If a student is chosen from a group, what is the probability that the student only plays tennis? Well, we know that the word only has been used, so we must be looking at just this part on the outside of the tennis circle. And it asks for a probability, so that means that we need a fraction. So that must mean that the answer of choosing someone who only plays tennis is 8 out of 19, because there's 19 things in total. 5 plus 6 is 11, 9, plus 8, 19. Let's look at another question. So a grade of 147 students, so 147 students, are to choose to study Mandarin or Spanish or both. 91 students chose Mandarin and 80 students chose Spanish. Okay, so let's write this down. We have 91 people in this circle, and we have 80 people in this circle. So, how many people did both, I wonder? Well, we can work this out, because if we were to draw our 2 circles, we should have 147 people in here. However, we don't. We have 91 plus 80 is equal to 171. Now this is much, much more than 147 people. So now we need to find how many people we've counted twice, because that's why there's too many people here. So what we can do is we can take 171 and we can minus the total. So we're going to minus 147. Now, that equals 24. So this means that there's 24 people we've counted twice. So that means that there's 24 people in the middle here. So let's redraw our Venn diagram. So we're going to have 24 people in the middle here. So now we just need to work out how many goes here. So if there's 80 people in total, and there's already 24, this must just be 80 minus 24, which is 56. And over here, it's 91 minus 24, which is 67. So, how many people have chosen both languages we know is 24. If a student is picked at random, what's the probability that they only chose Spanish? Well, this one over here was my Spanish. So 56 out of 147. Now, this question here has said, what is the probability that they have not or has not chosen Mandarin? So this circle over here was our Mandarin circle. Now, we do not want that circle. So what I like to do, I just like to scribble it out. So we don't want the Mandarin circle. We got rid of it all. So we can see that the answer would just be 56. But it wants it as a probability, so it needs to be a fraction. So the answer would be 56 out of 147. Let's have a look at this question here. So let's make a new page. Emma wants to sort a list of 11 terms based on whether they have a 3 in it. Now, a term is not just another word for a number. Now, term that has a 3 in it. Well, we can see here that this one here has a 3. This one here has a 3, and this one here has a 3. So because she wants the probability, we need to write it as a fraction. So 3 different numbers have a 3 in it. So there would be 3 out of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there'll be 3 out of 11. Right, so the next question is, it contains a 3 or is an odd number? So let's write out the numbers. 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and 144. Now, if it's a 3, I'm going to give it a tick, and if it's an odd number, I'm going to give it a tick. If it's both, I'm going to give it 2 ticks. So, we have an odd number, we have an odd number and a 3, we have an odd number, we have another odd number and a 3, an odd number, we have a 3, we have an odd number and an odd number. So you can see we have 1, 2, 3, 4, 5, 6, 7, 8. 8 different numbers out of the 11 that have a 3 or an odd number. Now the reason why I gave 2 ticks was so we could identify the numbers that have both. Because the next question asked is either an odd or a 3, but not both. These ones here contain a 3 and are both. So we're not going to want them this time. So the answer would just be 1, 2, 3, 4, 5, 6. So the last one would be 6 out of 11. So let's have a look at this one. The student is making a Venn diagram about politicians in the last 2 elections. Looking at a group of 24 politicians, so we know that there's 24 politicians. 14 ran in the first election, and 19 ran in the second election. So we have our 2 circles, and we have 14 and 19. Now immediately you should be able to see, and flag should happen, because 19 plus 14 is more than 24. So 14 plus 19 is equal to 33. So we need to find how many people go in the middle. So 33 people minus 24 is equal 9. So we've counted 9 people twice. So that means we have to redraw our Venn diagram with 9 people in the middle because 9 is here. And we need to work out what's left. So there's 14 people in this circle. So 9 plus 5 is 14. And 9 plus 10 is 19. So the number of politicians who was in at least one election, how many politicians ran in both elections? Well, we know it's 9. A politician is chosen in the second election. What is the probability that they were also in the first election? So this would just be 9 out of 19, because it asks if a politician is chosen in the second, what is the probability they were also in the first? So and also kind of mean the same thing in this circumstance. Hope this was helpful. Good luck with the rest of your questions.